Hi everyone, let's talk about tandem mass spec today. So tandem mass spec you'll also see referred to as MSMS because it's literally two mass spectrometers put together. It's quite a simple process, and we'll get to how each one works. Okay, so let's just look at a simple block diagram for an MSMS. So you have your sample unionized and you put it into a soft ionizer. Now remember, this is going to be things like MALDI, for example. There's other forms out there, but MALDI is by far the most popular in literature, so we'll go with MALDI. So, for example, if you use a MALDI, other sources could be stuff like EI, ESI, but we're not going to cover that really in this video. But remember, MALDI, I have a video on this. If you have a matrix, you have a laser beam, you have a sample, it's going to hit the sample and it's going to ionize it, but not fragment it. So you're going to get soft fragmentation. So let's assume our sample is AB. Okay, so our sample has the components AB to it. So when it goes to the soft ionizer, it won't fragment. It will stay AB, but it will have a positive charge somewhere. Let's also assume we have CD as well. Let's give it a different color. Okay, and let's say we also have CD plus coming there. So if you took a little microscope that could see these ions, you would see CD and AB plus, but they wouldn't be fragmenting. Now what you do next is you put a mass analyzer, and that's going to separate the two. So let's say at some voltage, some DC voltage, you get just AB. And let's say CD is emitted, so CD is emitted. Okay, so we're just kind of following the process of this tandem mass spec. So we have mass analyzer 1, and it selects for AB. Now that might be a different case. If we raise the voltage, then maybe we could select for CD, but in this case we select for AB. Now what we're going to do is go through this thing called an interaction cell, and this is typically nitrogen or argon gas that's going to bombard the softly ionized sample. It turns out that these AB ions are what we call metastable, and they're not quite that they're stable, but if they're provoked in a somewhat serious fashion, they can fragment, and that's what happens. We take argon or nitrogen gas, and let's say here's that vessel. Let's say there's an inflow of N2 here. Okay, we have a little N2 inflow. We have, let's say that's going to come in here, and with that reaction we're going to have AB plus, and when they collide, what's going to happen, you're going to get A plus, and you also might get B plus as well. So you'll get both species of fragments. Then what you do is you go through another mass spec. Okay, so if we zoomed in here, we would see this or this at the interaction cell. But what the mass analyzer second is doing just what MA1 did. It's just doing it for only A and B now. And what happens is, well, one, let's say B does not hit the detector and it picks up A. So let's say A goes to the detector. So this system is going to select for certain ions and only some certain ions, because what's going to happen, you have a pretty complex sample and more bigger than A, B, and CD. Let's say peptides, for example. Well, first you separate all the peptides out, you fragment the peptide, and then you put it through another mass analyzer, and it picks up maybe in that case specific residues in that sample. So you can see how this might be helpful, right? You can take very complex samples and break it down into its fundamental components. And in fact, when you get to even more complex molecules, you might even have MS, where you do this multiple times over. MS, MS, MS. And sometimes you can put so many of them together, we literally just call it MSN, where N is the number of mass spectrometers put in succession. And there's very specific cases for when you might use a triple MS or an MSN kind of layout. Now, there are specific kinds that you need to be aware of. And for one more thing, we need to discuss some. I forgot, I have this in my notes here. We have some terminology. So we call these ions the source ions. Okay, so these are source ions because they're everything. That's the whole mixture, the source. But AB plus is called precursor ions. Sorry, I know my handwriting's terrible, but these are precursor ions. All right, so CD, when it comes through at its respective voltage of Ma1, if I could just draw a nice circle around that, AB plus, that's the precursor ion, but CD could also be a precursor ion if it made it through, but specifically we're looking at only A plus getting through, and that requires AB to get through the first one. Okay, and then what we call these ions here, these are product ions. Okay, so these are product ions. So keep that terminology in mind for when you might read some literature on Tandem MS or any of these other MS kind of ideas. Okay, so let's talk about two specific setups. We're going to talk first about Q, Q, Q. So what we're going to do here is we're going to define the specific mass analyzers that we use. So MA1 and MA2 are ambiguous. It could be time of flight. It could be an actual quadrupole. It could be a magnetic selecting mass analyzer. So it depends. And one of the first ones is QQQ. And what this will be is you're going to have an ion source. So same as the beginning, soft ions come through. Q1 is going to be a quadrupole. So I'll just draw a little diagram of a quadrupole. So Q1 is a quadrupole. And then you go to a collision cell, and that's what this was. The interaction cell, when you're colliding gas molecules with it, we call it a colliding cell. And notice this process we call collision-induced dissociation. It's in the name, collision, because they're colliding. Induced, it's inducing what comes next, which is dissociation. Okay, so that's where that terminology is coming from. But we call this a colliding cell. So we'll just draw a little diagram of a collision cell. And then what we have is another quadrupole. This is among the simplest. This will be Q3. This is another quadrupole. And hopefully you can follow that. It shouldn't be that difficult to wrap your head around. We have soft ions coming through. It selects out for only one of the soft ions. It fragments that collision cell up, and then it moves through another quadrupole system. And then, of course, you reach the detector. So that's QQQ setup. Now let's talk about the other one that I wanted to discuss in this video, Q time of flight, or QTOF. Okay, so in this one, again, you have the ion source, but it's kind of like MALDI-TOF, where you can literally just hook up a MALDI-TOF. You do TOF instead of a quadrupole. So instead of physically selecting in space for those ions, you go for a time of flight method instead. you go to the collision cell. So what you kind of want to look at this is it's kind of like chromatography. These things travel in bands. You're going to get this first band, and let's say you have this green molecule and you have this orange molecule. They're just ambiguous. They're going to reach the detector, or in this case, the collision cell, at different times. The collision cell is going to chop up green into like all these little bits and pieces, right? All the different separate fragments that it can get. And it's going to reach this at some different time than the orange ones when they get fragmented. So these orange fragments are happening at a later time in the future from the green ones. And then it just goes to a simple quadrupole, which I'll call Q, where they're going to move through, and these green species are going to select differently in time, you could say, where then once all the green has moved through, then the orange moves through. Again, this is happening at a very, very small time scale, like milliseconds. And then the orange will get to the detector, or sorry, the quadrupole, and it will begin to undergo all the mass analyzation and separation. And evidently, they're all going to hit the detector at different respective times, but first the green, and then secondly the orange. Okay, so hopefully you can see the differences. The only difference between the two is that there's no time of flight in QQQ, but in QTOF there is a time of flight detector, or sorry, mass analyzer. Geez, I need to get this terminology down. I don't know what I'm doing. But that is the entirety of this video. If you guys have any questions, you can drop them in the comments. But I hope that you have a wonderful day. Bye-bye.